How's it going, everyone? Javier Gonzalez here again. Looking at this particularly exercise from NeetCode, which is what we're gonna see today. Which now NeetCode is this particularly LeetCode problem solutions made by Nativ Singh, a software engineer that previously worked at Capital One and Google as an intern. And the idea here is to see how we can use all of these data structures like uh, all of these data structures like algorithms in data structure, as I mentioned before, to see how we can come up with some solutions and understand the pattern when it comes to use them to solve those problems. So, because we have now arrays, we have um, stack, queues, linked list, double linked list, binary search as an algorithm, as well as sorting algorithm. Uh, See how all of this actually works, specifically in ECMAScript. So, the methodology here is to define this 45 minutes as a way to, on the first 10 minutes, we're going to look at recap of what we have learned so far to understand what is the value proposition of all of this different exercise that we have learned from, or that we have practiced. And then 20 minutes to think about the problems, and if we weren't able to come up with some solution, then take a look at the solution provided by the NeetCode. So, because here initially we're starting with this roadmap as the array and hashing, and now we're currently going to take a look at the two-pointer problems as well as the stack, which are the most. I will argue that this is the favorite solution problems for companies as a way to get in there and understand how all of these things works. And now on the array and hashing, this is a way to see first how you can now count duplicates in a particular collections using now the built-in tools, for example in JavaScript like set, that it can do that thing for us. Similar for the valid anagram. Hey, can we now actually see if these two particular words actually are the same? So by getting those words, transforming into an array, and before that you turn. So taking those two strings, putting into a lowercase to make all of those strings the same when it comes to compare. Once you transform them into an array and using the sort method as a way to compare these words and sort them in an alphabetical order, particularly using is the UTF-16 code point table. And once you get that elements already sorted, all of that are an array, okay? Then you're going to transform that into a string and compare them. So that's pretty much the way of how you can actually do this kind of things by working is with arrays and strings. See how you transform one of them, see how you can apply particularly useful methods that they provide to us, all right? And also understand what is the benefit of using this specific methods to solve common problems. So you don't have to actually write your own solutions. And in fact, you can use this already methods for that. Okay. And the other is in, well, the valid anagram, the do sum, which is quite interesting as a way to see now how you can use your hash map as a way to represent them in, yeah, as a way to represent them to now count elements here in particularly for this to sum, which the idea here is to find in a collection of elements is what are the so what is the index in which what is the two numbers they want to know is what is the index of two numbers so when they add up it match a target. So the idea here is so by using now is and a hash, so you can go with the double iteration as a way to iterate through each one of those elements and to compare that. The big O notation for that is n squared, which is something that you don't want to. It's horrible, by the way. But we can do this into an ON or linear time. So no matter how many elements do we have, it will take us linear time. And the idea here is using now a map as a way to actually, anytime we are looking is at these particular elements, we want to know when we subtract that element, we want to store is the complement in our hash as a key and the value as a value, right? So every time we iterate through that, we're going to ask for that. Hey, is this different actually, which is the complement number? It is in our records. If it is, all right, provide it. If it's not, that's going to add this number. And that's quite interesting, and that's something very, very, very interesting as a way to start to develop this particular sense of what are the things that you can use with hash. So you can use your hash as a way to compare with that. And also, we also look at group anagrams, how you can use your hash as a way to now group elements. And top K frequency in string encode and decode are actually very interesting exercise because this is most likely something that you're going to see a lot of in your daily day and something that you might find useful as a way to solve real life problems. For example, the most K frequent elements, okay? Whether it is what is the most place that you have visited in the last 2 weeks, or the last or the most common or the most frequent restaurant you have went over the past 3 months, or what is the most frequent snack bars, ice creams, or food that you spend more. Okay, so that kind of thing is a way to know all of this frequency, and which is the foundation of these statistics. And I think that's quite interesting, very, very interesting. All right, so yes, the top K frequent elements, and then we look at the string encode and decode as a way to see how you can now put some additional information as you encode some data in a string, and then use that information to extract that data from that. And to me it was like beautiful. This is something beautiful. And it is beautiful because cryptography is beautiful because the ability or the thing that it can allow you to do that. The thing it can allow you to do that. So then we look at the product array itself, right, as a way to calculate the prefix and the postfix. Valid Sudoku as a way to actually see how you can now is giving a particular matrix, how you can now represent is matrix, and how you can now locate that pretty much like a battlefield, all right, in which quadrant you belongs to that, as well as the valid palindrome. This is more like to get is a particular string and remove any of the non alphanumeric characters, okay? And once you get, because after all, a palindrome is just a word, a phrase, unlike a word, it's a phrase, and when you take out of it is non-alphanumeric characters, and then you reverse that, they are the same, right? It's the same back and forward without any of the non-alphanumeric characters. So this is the valid palindrome. And how do you can do that? Well, by actually getting this string, and because we can use this nice little convenient function called match that is going to use a regular expressions, so we can evaluate is which one of these character actually is a letter or is a number, and then add that to our palindrome string. Okay, once you get that, you're going to transform that into an array, reverse that, and see if they actually are the same, right? So this is also something that we are going to use a lot of the time, especially software engineering, where we are going to work with collections of values and sequence of them. So this is the fundamentals, especially in a lot of people that actually are looking for backend developers are desperately looking for an exceptional rock star backend developers. So to solve those particular problems, which is how they come up and how they can now work with this sequence of elements in the most effective and efficient way. So yeah, valid palindrome. The other is what valid parentheses, and this was another interesting challenge, where the idea here is by looking at a particular format of valid parentheses, how you can actually validate if a given string contain is a valid parenthesis. And most of the time when the order here matters, stack is your friend, okay? And you can use now a hash to actually compare which one of these particular elements are in there. So I think this is something quite interesting to work with and to go along with as well. Mm-hmm. Mm-hmm. As a way to develop this sense when it comes to know when to use a stack and when to use a hash as a way to compare that. But what we really care about in today's video is one of the very interesting problems of today, which is day 9. All right. To sum 2 with input array is sorted, right? This is it. Input array sorted. Input array sorted. Okay. Good. Good. Valid palindrome. In today's we're gonna focus our attention is into this. We're gonna do some input array. I already actually make some algorithm, but I know that wasn't the case. Let me actually put this here. Put this solution here. Actually is pending, right? This is another exercise, pending exercise as well. To sum 2, input array is sorted. Okay. And we already have now, read this because we're going to receive this input already sorted. We want to know is which one of those index are, which one of those numbers, when they add up, match to the target, right? So let these two numbers, that'll be the numbers in the position 1 and in the position 2, that'll be is those numbers are guaranteed that they're going to be less. Okay, or the first elements you're going to find, it'll be in the last position than the other elements that is at the complement of the higher position, right? So because of this, and we actually are using right now is this particular example. Let me see if I can show you this. All right, I want to in fact show you is this. Ba, 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 ba. There you know it's Figma. Figma item. Figma this one. Okay. All right. So because we got our collection sorted, and the target here is 7. This is our target. Okay. So the idea here is that those particular numbers, we know that there will be is at this range. So by looking at these collections, we know that 3 plus 4 actually match to 7. And there is no other elements in the sequence that actually match to that, right? So it is only one solution, okay? And that's one of the things that you need to specify first. So part of the mental model of thinking forward is that clarify what, or start from the thing that you can clarify quickly, which is, in our case, is that what will be the inputs and the outputs. In this case, we already know what will be the inputs, and we want to know is that the output will be is yeah, and the output yeah, we know that this will be the input. Okay, we know that this will be the input. So what will be the input and the output? All right. So our input will be is now an array of these collections of values. Actually, I'm not looking at the keyboard, which to me is amazing. I developed this second sense here. And the output will be as well, give me those index. So starting and add a 1 to that. 1, 2, 3, 4, which is 4, and 5 for that. That will be the output. So this is the input and a collection, followed by this target value, which is 7 in our case. Okay. So because there is only one solution, okay, and you might not use the same element twice, okay, so it's like, hey, please, okay, you might not use the same element twice, which is one way we can think of this is that iterate through this collection and then compare these two numbers, and then if this actually match to that, we know, well, we move on to the next one, but as you can see, we are comparing is the first element here. Is minus 7 plus 1 is 7? No. And let's go to compare that with the 3. Is minus 7 plus 3 7? No. But as you can see, we are comparing is always with the same first element here. But that's not what we want. We want is now to not use that. And the other, you say your solution must only use constant extra space. So we can use in other words, use only variables for that. So what we can do is here is to, well, hold a reference of these particular elements here at the beginning and at the last. So, but the thing here is that what will be the comparison, what will be the algorithm, the series of steps that we need to do as a way to calculate this one, as a way to obtain this one. One way we can do is to say, well, let's going to say let's going to now add the elements at that position, okay, which is this in turn will be is now 6. All right. So since this is a positive number, okay, the question will be is that what do we do with this information? Okay. Exactly. So what do we do with this information? So far we know that that is a okay. So with this information, what we can do is to actually is use that and compare that to ask a question. Is the result of this? It's gonna call this result, right? This is the result of this expression. Okay. So the result of this is this one. But what we want to do now with that result, you know, because now that we calculate that, and since if the result is greater than the target, which is in our case 6, all right, in this case, well, is not true. All right, is not true. Hey, result is greater than 7, and now it's not true. We know that we need to move is the index at the most left position, which is this one. Why is that? Because now we have the information needs to say, hey, which one of this we need to move and at which direction we need to move them, right? So in this case, what we do is to is going to see here, hey, to ask this question for the first iteration, where in the F because I'm using is 2 keyword layout, that's what happened. What in the F is this? Holy moly. It's because it's only available in Spanish. Yeah, it's only available in Spanish. Yeah, I think, yeah, it's only available in Spanish there. In any case, let's gonna leave like that, right? Yeah, it's only leave like that. So is this one. So we're gonna calculate is the 2 pointer here, the value of those pointer, We also can say something like this. It's like, hey, say left value, it is -7. All right, which is left value -7. The other is left value, right value, which is now 13. So what we're doing here is to say, hey, we want to know is the left value plus the right value. Okay, so we want to know is the difference from this. Okay, we want to know is the difference. Okay, which in our case is actually 6. All right. So is the difference value greater than the target? Or in this case, we can, in this case, target. So let me actually put now target here as 7. Say target. Sorry, target. That's right. Target. All right. Okay, so we want to now actually do is this. Hey, is it different? You say, hey, let's going to calculate is the difference of the left and right, and we're going to compare that with the target. If that difference is greater than the target, it means that we need to actually is move the right element. So we need to decrease the right element. So based on this, okay, based on this, well, we're gonna do something like this. Exactly. So based on this, okay, so if it is true, okay, if it is true, what in the F is this? Okay. If this is true or this is false. Good. If this is true or this is false, right? So if this is true, that the difference is greater than the target, we need to actually is decrease or move left value to the or move the left value to the left. Move the left value to the left, right? Move the left value to the left. Otherwise, we need to actually move is the right value to the right. Okay. We move the right value to the right. And then we need to update those values. Okay. And we need to update those values, which is now update left value. Exactly. So update left value. So and update right value. Right. So as we do this, okay. So for the first iteration, here the difference is 6. which is greater than the target. Okay, is greater than the target. If it is greater or equal than the target, oh my god, there we got it. Okay. If it is greater or equal than the target, so the point of this is actually where we're going to move. In this case, because 6 is not greater than the target, we go move to the left. We go and move the less value to the left. All right. We update that value now with the -2. Okay, and then we do this again. Left value is now 2 minus 13. Okay, which is in this particular iteration is the in this particular iteration is the 11. All right, so this difference is greater or equal than the target. In fact, it is greater, so we're not going to move is the right value to the right. Okay, like so. That's right. And we're going to update now the right value here with 5. Okay, and then we're going to calculate is this different. We say, hey, -2. When you add that to 5, it's actually 3. So 3 is greater than the target. No, which means that if the difference is less than the target, okay, if the difference is less than the target, you're going to move is now the less one. Exactly. If the difference is less than the target, this is true and this is false. Okay. Hey, is the difference is 3 greater or equal than 7? No. So you're gonna move is now the left elements here at that moment. Okay. You're going to update now the left value as well, which is now it is 1. And when you say, hey, is when you add these two number, which is now 6, you ask yourself, hey, is the difference is 6 greater or equal than the target? Is actually not true. So I want you to move is the elements of the left position to this. All right, and now update that to 3. Ask again the question. Okay, and you say, hey, if the difference is greater or equal than the target, well, I want you to now, yeah, it is true. I want you to now move the element from the right position, which is in this case this one. All right, update that value, and then when you add this, all right, 3 plus 4 is actually 7. So it's 7. You need to actually ask, is these two values here? So this will be is the instead of difference. Or is this a match? That will be much more adequate to call that match. And if that match is actually, and here's when you're gonna ask yourself, hey, if this match actually if this match is equal to the 7, all right, after all you want to return is the index. Okay, so you're going to return the index of the left and right? Pretty simple. Exactly. It's pretty simple. Exactly. It's pretty simple. Which is this one as well. Like so. You're going to ask this. And this is true. Return the index. If this is full, well, I want you to now think of this. Like so. So, actually, this is it. This is our algorithm. Now let's actually put this, and let's gonna make this 2 finally is put it into the code. So let's go into now into our code. I think this is quite interesting. This is a very interesting image here. That's right. So you can call this as the target. All right. Yep. You can actually is copy and paste as an SVG. That's right. And then we want to paste that here in this one. Please paste that. What in the F? Oh, okay, it's pasting that as an in. Okay. You think you're funny? Well, I want to copy this as a PNG. That's right. Paste it. There you go. Okay. Yep. Let's go to now implement this. All right. So the whole point of this is to do this. Okay, so because we want is to, let's jump back to the code here, because after all we want is to define a left and a right. Okay, so a left, this must be actually left as a variables left, and the subtle difference between let and count is you can so they are now blocks. They are now so the once you use let or counts is because you are going to define your variables per block scope, not per function scope, which is something that is what you do when you use var. Okay. And let allows you to mutate the value of the label, or the the value of the labels that you put in your variables, whereas cons it won't allow you to mutate the value type. Okay. However, it allows you to mutate is the value type of the yeah, it allows you to mutate the value type of the nested objects. So for example, for top level objects, it won't allow you to mutate that. For example here, so if you define here, hey, this is now an object, right? And then you say, hey, I want you to now mutate is the name to have now this. So this will be John or Joe, right? And the age is 27, right? So here you are now, if you want to do this like age, you can mutate that without any issue, all right? But the object itself, you can reassign that to another variable. So for example, or to another type. So for example, let's say an array. Say 1, 2, and 3. You say, you can do that. Type error. You can also you can reassign that with other object. You say, you can do that. Even though you can do something like this, which is valid, as a way to update that reference. Say, hey, now it is John. But if you don't pass is the other one property, for example, like age, it won't allow you to do this, because what you're doing is just reassigning a new value to these objects. However, you can reassign values to the property inside of the object. In other words, you can reassign a new value in that space where it's already located. So this is a way to now prevent some, or to promote, is the immutable data. So once you use the data, you cannot, or you shouldn't mutate that state. And that's one of the reasons why solid principle came around and that kind of thing. All right. So yes, here we're going to define is now the left here as 0. The same for right, as 0. Okay, and I want now 2 is also in this particular case. I would like is to now is define the iterable here. So you might wonder how many times we're going to iterate through these elements. Glad you ask. We're gonna iterate through until there is no more elements here. Right? So we want to iterate through all of these elements one time, but for each time we iterate through this collection, we want to see when we need to move our pointers until we find them. Right? So one way to do this is by saying, I want you to now iterate through all of these numbers for each, okay? And because at the end of the day, we want is to generate is where is the index that you find that as an array, we can define as a map here as a way to return that new index, all right, or that index suspected, where here we're gonna have is our number or num followed by the index, okay, and here's where we're going to apply now that particular logic that we did back then. So here we're gonna update is the left, okay. So now the left will be is the, so these left values will be is whatever we have in the numbers at the left position, which is the index, right? And the other is the right, that is the numbers at the okay. We want is to now is assign this, okay, to the first elements in the array, and then to the last element in the array, which is numbers dot length. We can read this property here. Okay, -1. All right. So now that we got is this element, okay, we want is to actually see when you add them. Okay, so when you add them, if they match. So here we're gonna say, hey, is this match? Cons is, hey, is the left plus right value plus right actually match? Okay, so if match is the same as the target, okay, if it is, well, return now is this array that will contain is the left we need to actually is store that pointer. Okay, we need to actually store that pointer, not the value. Okay, we need to store is the pointer here, which is initially 0 and the last element here. Okay, so this is our pointers here. So once you now add these numbers, say index, that's right, or in this case it must be like this. I will in fact use now a for loop because it is much more easy to work with for this kind of problem. Say for, let me define here a variable index here, which is equal to 0. All right, and you're going to iterate until the array dot length, the numbers dot length, okay, -1. Or in this case, you want to iterate until that is the last number. All right, and after through increment that index. So right, okay, so because the first time is like, hey, what'll be is the what'll be is the left, okay, or in our case what'll be the numbers at that left position and the numbers at that right position, okay, and if there is a match, I want you to now return is, well, the index of that, which is left and right, right? You want to return is the index for that plus 1, because this is something that now the example is telling you to do. Plus 1, all right? And add by 1 as an integer of that. Good. So if not a match, okay, if that is not a match, well, I want now you to is evaluate this particular case, which is if the match. So if the match is greater or equal than the target, if it is true, we want is to now update is the rightmost value there. You say, hey, right, okay, will be now is numbers. Yeah, right will be now is numbers dot length. I mean it'll be now -1. like so. Because we want us to decrement that by itself. Okay, which is actually updating that. Which is updating. Otherwise, well, is left that needs to be incremented. And that'll be all. If after you iterate through all of these elements you weren't able to find the result, return empty array. So when you run this, oh, it's here. So when you run this, it's because it's Jesus. All right. Human error, as usual. Here we say return left and right. This is right, right and left. Exactly. There is some misspelling there. And there you got it. Similar to this, there's another misspelling there. Right. And holy moly, that actually works. Nigga, that actually works. If I submit this, okay, and that actually works. Holy moly. That's interesting. In terms of memory, it's like, you could do better. You could do better, I know. But in terms of runtime, it's like, yeah. Your solution actually is quite interesting. Exactly. Your solution is actually quite interesting. Yeah, it is. Holy moly. I hope you can enjoy that. That was quite interesting to solve this. Alright, as a way to work with these 2 pointers algorithm. And with that, that'll be all for this video. Take care. Bye bye.